Alright, so in this video we go over section 7.4, which covers improper integrals. So in this case we are going to evaluate integrals in which at least one or both of the limits of integration are going to infinity, as we can see in the symbol right here. So what does it mean to evaluate an improper integral? Well, although there's other cases of improper integrals, we're going to go with the simplest case for this class, in which we consider the area under a curve, but we integrate all the way to positive infinity or negative, or both sides of the infinities. So we are going to evaluate the integrals using the exact same rules that we have been studying since day one. However, when we get the final answer for the integral, we are going to make a conclusion of the integral. So if the limit, so we are going to convert the integral into a limit, and then we are going to evaluate the limit. If the limit exists, then we say that the improper integral is convergent or converges. Otherwise, the limit does not exist, the integral diverges. So let's go ahead and do a couple of examples. So let's evaluate the improper integral. So first of all, let's change the notation. Let's change the limit as of the integral from 1 to b of 1 over x squared dx as b approaches infinity. So we are going to evaluate the integral as we would normally do. Limit b approaches infinity from 1 to b, x to the negative 2 dx. So in this case, when the integral of x to the negative 2 by the general power rule, we get negative 1 over negative x to the negative 1 in the first place, evaluated from 1 to b, which is the same as limit b approaches infinity of negative 1 over x, evaluated from 1 to b. And we are going to evaluate upper minus lower, which is going to give us negative 1 over b minus negative, be careful with signs here, 1 over 1. Actually, I'm going to use brackets here. And you might want to use the smiley rule here, turn that into positive, and this will become the following. I'm going to write this positive term first, which is going to be 1 minus 1 over b. So if you plug in, if you evaluate this limit, so I'm going to plug in infinity, 1 minus 1 over infinity. But what happens when we evaluate, when we divide by infinity? Dividing by infinity, dividing by something huge, it's going to give us nothing. That's going to go to 0. So in this case, we get 1 minus 0, which is 1. Final answer. So in this case, we say that the integral converges. And that is because the limit exists. Let's look at case B. Let's look at another example. So basically the same thing. Let's write the integral with the upper limit in terms of a limit. Limit b approaches infinity of the integral from 0 to b of the square root of x dx at the top. I'm going to use laws of exponents to rather radicals to rewrite this integral. So I'm going to have the integral from 0 to b, x to the 1/2 in the denominator first, and then I'm going to move this x to the positive 1/2 to the numerator with negative exponent in a way that we can evaluate that integral. Okay, we still keep the limit 0 to b, evaluate this, add 1 to the exponent, we get limit b approaches infinity, x to the 1/2 divided by 1/2. So if you add 1 to negative 1/2, we get positive 1/2, evaluated from 0 to b. So now it's time to rewrite this. I'm going to write the reciprocal of 1/2. So I'm going to have limit as b approaches infinity, and that's 2 times the square root of x, evaluated from 0 to b. Evaluating upper minus lower, at the same time I can pull out this numerical coefficient, these two. I can pull it outside of the limit symbol, and so we don't have to do too many computations. So 2 times the limit b approaches infinity of the square root of b minus the square root of 0, which in this case the square root of 0 is just going to be 0. So we're going to have 2 times the limit as b approaches infinity of the square root of b. If we evaluate this limit at b equals infinity, we are going to get the square root of infinity. But what is the square root of infinity? That's going to be infinity, 2 times infinity. And 2 times infinity is still infinity. So in other words, in this case, the limit does not exist. So we say that the integral diverges. All right. So the integral diverges in this case. Let's look at the second case of integral of improper integrals, in which in this case we evaluate from negative infinity to a number. So that is in the other direction. Let's do one example. The conclusions are the same. The limit exists. The integral converges. Otherwise, the limit does not exist. The integral is said to be divergent or diverges. So in this case, the picture of this is we integrate to infinity in the negative direction. All right. So let's do one example. So let's write this into limit notation. So in this case, I'm going to write a because that's going to be our lower limit of integration. And then write the integral from a, the 0 of e to the negative x dx. So in this case, we are going to integrate this simple exponential function. So this is going to be the limit of negative e to the negative x, evaluated from a, the 0, as a approaches infinity. Okay, I'm gonna clean up all the parentheses and all these negative signs. This negative sign is the same as having a negative one in the front, which I will write in front of the limit, and I'm going to erase those parentheses as well. So this will be limit as a approaches infinity, actually negative, of e to the negative x evaluated from a to 0. So this will be negative e to the negative 0 minus e to the negative a. All right. So what are we going to get in this case? Well, so in this case, e to the negative 0 is the same as just e to the 0, which is 1. Any quantity to the 0 power is always 1. Actually, oh, never mind. I forgot the limit symbol here. Limit negative a approaches infinity. and I'm gonna have negative limit as a approaches infinity of 1 minus e to the negative a. Okay, so we evaluate this limit. By the way, it's negative infinity, negative infinity. So I'm going to get the following. 1 minus e to the negative infinity. Okay, this will become a positive number. So I'm going to have 1 minus e to the infinity. But what is e to the infinity? E to the big, it's still big. And 1 minus infinity, what is that going to give us? That's going to give us negative infinity. So in this case, the limit does not exist. So the integral diverges. Okay. Let's look at the third and last case. A case in which we are going to break the problem up into two pieces. When we that's what happens when we integrate with both numbers, with both limits of integration are infinity, negative infinity and positive infinity. So all we do is write it in two separate integrals. In this case, it would be a good idea to specify that this 0 right here can be any number. However, typically we choose 0 because that doesn't always work. There are cases in which it may not work. All right, so let's see. So I might make up an example in which it's not going to work. Okay, so let's write this in terms of two limits. So in this case, I'm going to write the integral from actually the limit as a approaches negative infinity of the integral from a to 0 of x e to the negative x squared dx plus the limit from 0 to b as b approaches infinity of x e to the negative x squared dx. All right, so let's see what are we going to do. So in this case, notice we have to evaluate the same integral. So in an effort not to do the same problem twice, I'm going to use a different color to do some scratch work. So the integral of x e to the negative x squared dx, that will be, we would need a u substitution in which negative x squared would play the role of u, and du will be negative 2x dx. So in this case, we need negative 2 that is missing in the integrand, provided we divide one out. That way we will get the u du completely. So this will be negative 1/2 times the integral of e to the u du, whose final answer will be negative 1/2 e to the u, and back substituting, get plus c. Well, actually I'm going to omit the plus c because we're going to have limits of integration. This is going to be negative 1/2 e to the negative x squared. So I'm going to box this. I'm going to box this, and I'm going to continue here. So what are we going to get? For the first limit, a approaches negative infinity of the integral of negative 1/2 e to the negative x squared evaluated from a to 0 On the other hand, we are going to have the limit b approaches positive infinity of the integral from 0 to b of negative, or not the integral anymore. Let me erase this part real quick. We're no longer integrating. So we're going to have also negative 1/2 e to the negative x squared from 0 to b. Okay, so I'm going to write this again. I'm going to take out the coefficients, negative 1/2 times the limit a approaches negative infinity of e to the negative x squared minus 1/2 that evaluated from a to 0 minus the limit b approaches infinity of e to the negative x squared from 0 to b. Let's evaluate each of them. So I'm going to evaluate the first one, negative 1/2 times the limit e to the negative 0 squared minus e to the negative a squared as a approaches negative infinity, and then minus 1/2 the limit of e to the negative b squared minus e to the 0 squared. We'll make this looks like so. E to the 0 negative infinity, that's going to be 1 minus e to the negative a squared. We don't evaluate the limit yet. We are simplifying the expressions first. Minus 1/2, I missed the 1/2, minus 1/2, limit b approaches positive, and this is negative infinity, by the way, this is positive to positive infinity, e to the negative b squared minus 1. So now we evaluate the limit, plug in infinity over here and negative infinity over here and positive infinity over there. So we are going to have the following. No more limit symbol, no more limit word. What we do, negative 1/2 times 1 minus e to the negative infinity quantity squared minus 1/2 e to the negative infinity squared minus 1. So that's what we are going to get here. Be careful here when multiplying these signs. We cannot multiply this negative times a negative. It actually gets affected by the power. So we're going to get a negative infinity squared, which is going to become a positive infinity times this negative will become negative again. So negative 1/2. 1 minus e to the negative infinity minus 1/2 e to the infinity squared. It's also positive infinity times a negative is negative infinity minus 1. Okay, in this case, this guy right here is going to go to 0, 0, and the terms that survive are going to be negative 1/2 times 1 minus 0 minus 1/2 times 0 minus 1. 1 minus 0 is 1 times negative 1 half is negative 1 half. 0 minus 1 is negative 1 times negative 1 half is positive 1 half. In this case, adding these two, we get 0, which is the final answer to this problem. So in this case, we got a number. That means the integral converges. And this is the end of this section. I'll see you on the next video.